Sometimes we use natural sources of mechanical energy like wind or flowing water. And sometimes we create our own mechanical energy from natural resources. Here we see examples of different kinds of power plants that uh, that that humans have built. On the left, we see a fossil fuel plant. This is a coal burning power plant. In the middle, we see a nuclear power plant. And on the right, we see a geothermal power plant. Each of these have advantages and disadvantages, just like different kinds of naturally occurring mechanical energy have advantages and disadvantages. Generally speaking, the one big advantage of the energy sources we've already looked at, like hydroelectric and wind and tidal energy, is that they are either inexhaustible, they'll last forever, or they are renewable. So so we don't have to worry about them running out, and they tend not to they tend not to directly contribute to air and water pollution. However, we can't forget that all of these ways of harnessing energy do have environmental impacts. If you dam a river, you are changing that ecosystem for everything in the area. If you build huge wind farms in the desert, uh, you are also impacting that ecosystem, and you are creating a permanent structure that's what we have now. We have a large area of wind farms. However, to a lot of people, these are preferable to the most common, what are currently the most common ways of generating electricity. We get most of our electricity from burning fossil fuels. And when we burn fossil fuels, we convert thermal energy into mechanical energy. So we have this intermediate uh, process of we have a bunch of chemical energy stored in the fossil fuels. We burn the fossil fuels to release thermal energy, and then the thermal energy is transferred into mechanical energy. So there are multiple steps to the energy transformation, because the mechanical energy is then converted into electrical energy. So power plants that use heat or thermal energy or the generation of thermal energy and transfer of it to produce electrical energy are called thermoelectric power plants. All three of these power plants that we see are various kinds of thermoelectric power plants. Some of them will burn oil or coal. In the US, we have a lot of coal burning power plants. A lot of our energy comes from coal. We can also burn natural gas, and these can generate heat. You can also, you can burn natural gas directly in your home to generate heat. Geothermal plants use the internal thermal energy of the earth. There are certain places in the world where the geothermal energy is accessible from the surface. And these are places where you encounter things like geysers or volcanoes. Of course, these are places where we can recognize that internal thermal energy is accessible to us, and we can use that to um, to create or to generate electrical energy. A nuclear power plants are rather interesting because in a lot of ways they are, they don't produce the pollutants, the same pollutants that fossil fuel plants do. All of this, well, most of what you see coming out of the top of the stacks in a nuclear power plant, that's mostly just steam. And so in some ways nuclear power plants can be much cleaner, but in other ways they are, of course, more dangerous. And when the fuel is not contained very well or not disposed of properly, it creates great health risks. So nuclear power plants are controversial because they have great benefits and they have great risks as well. So some people consider them to be a great source of electrical energy, especially as the technology improves, because the technology has improved over um, the past few decades since we first started using nuclear energy. But then there are always risks because the fuel is so dangerous. It must be contained, and a lot of what we see in a nuclear power plant is just big, thick walls of concrete to contain that nuclear fuel. And then once it's spent, once it's used up, we also have a challenge of disposing of it safely. And of course, as we saw in Japan several years ago, you have the risk of damage, like we saw at the Fukushima power plant, where it was hit by a tidal wave, and you just can't plan for every natural disaster. So how does thermal energy get converted into electrical energy? Well, in a thermoelectric power plant, you have a thermal energy source, which might be burning fossil fuels. It might be nuclear fission. It might be geothermal energy. It's some kind of thermal energy source that that provides that thermal energy and transfers it into water. Water is heated up enough so it turns into steam. And then when steam is formed from water, it expands. So that expanding steam will, remember when a gas expands, it does work on its surroundings. So that expanding gas will do work on the steam turbine. It will transfer energy to the turbine, cause the turbine to turn. And then the turbine is attached to a generator that generates electricity, carries it away in electrical wires, and then the steam is cooled down and it's condensed back into water. So we have this cycle of boiling and condensing of water that 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 drives the turning of the turbine, because again, expanding gases do work on their surroundings. So why might a country want to replace power plants that rely on burning fossil fuels for thermal energy? Well, let's think about the comparison of thermoelectric plants to other kinds of power plants. Thermoelectric power plants have to use some source of thermal energy. They have to transform water into steam. Uh, and then there's a bigger environmental impact. Each method of thermal energy generation has costs and benefits. Nuclear fission doesn't require many ongoing inputs. The nuclear fuel lasts a long time, but it produces this hazardous waste that's difficult to dispose of safely. We have some solutions for what to do with that, but we don't have a lot of great solutions. So, what do you do with the waste, the radioactive waste from a nuclear power plant once it's no longer effective uh, for use in the power plant? Geothermal power stations require fewer inputs. We have thermal energy that's generated inside the earth that we can harness, but they need to be located over volcanic hotspots. It's hard to build things over volcanic hotspots, and it's hard to staff those places. They are associated with increased seismic activity. They're dangerous places to work. They're dangerous places to build, and there are only so many places in the world where you can build geothermal power plants. Hydrocarbon burning plants or fossil fuel burning plants use inexpensive fuels. Fossil fuels have been a tremendous of tremendous benefit to human civilization, because they represent a cheap, easily accessible energy source. However, they've also created some harm because the burning of hydrocarbons releases large amounts of carbon dioxide, which we've only recently learned is dangerous. And they also release things like sulfur compounds into the atmosphere, which we've known for a long time is a pollutant, and this CO2 and sulfur compounds damage human health and contribute to climate change, and that's an increasing concern. So fossil fuels, they're a rich source of energy. They're fairly easy to access, but there is also a limited supply. Eventually, they're going to run out. They're they're also available only in certain parts of the world. We are lucky enough to have a good supply of fossil fuels in the United States, but there are other places in the world. Well, there are certain places in the world where fossil fuels are plentiful, in certain places when they're not. And this relative richness and scarcity of fossil fuels creates a lot of geopolitical issues that are also important to us, even if it doesn't directly relate to the physics of energy generation.